Hi,
Oh, hi, Christina. How are you?
I'm
Oh,
good. How are you?
oh, good. Do you have any questions or anything?
No, not about the last test was pretty easy.
Okay.
I did look over this chapter. It looks like kind of difficult, but I think I'll be
Oh,
okay.
the 8.3.
Like the one that we're doing this week. Yeah, I
Yeah.
looked over it and I was like, but I think I'll be okay.
Yeah, I'm guessing that you will be, but I will say that I mean we'll do some examples like usual, but I feel like the main thing is just that a lot of these formulas are like exactly the same formulas like over and over and over again. So I'd say that where did I put it? Because yeah, so in the document, um the Google Drive folder where that table was at, the second page was some of the identities. So I feel like I haven't really like referenced like that page as often because it just hasn't like come up that we have needed some of these, but the ones that we have like, talked about, I'd say the most were from like from this box right here, the reciprocal identities, but I, like honestly, like my favorite one out of all of them is probably the one, and I'll show you real quickly because I know that this one, if I might have to just print it out because I have it in a hard copy, but I think it's downstairs. So, but I'll print it out then real quickly. But I'll show you the one that I actually think is probably better than that one, even is in those links that I posted. And if you lose the folder at any point, just let me know. But it's really this one right here, trigonometry reference card. And so this one I got from a book that you can't even get it anymore. It went out of you can probably buy it used or something, but it actually is, oh no, like that actually didn't, I'll just have to download it, but that's where I would actually go. But this week or this chapter will be this box, this box, this box. So these three right here. But I, like I think that having them all on one page isn't necessarily a bad idea, but we'll just start by doing a few of them and then if you have questions, just let me know. But let me print these so that I can actually like look for it again because I know that the second page, and it's actually in the actual book, it folds up into like a brochure. So that's sort of why I like it, but it really does have most of the things you would need along with some of the other formulas that you might actually um, have have forgotten. But here, so let's look at this one. So this is chapter 8B. And so the first one I'll do, we'll go in order like usual, hopefully. So 8 point, I don't No, I don't remember the section number, so I really thought that I had it, but hold on, let me see, because I don't want you to like, not have it, but this one. Okay, so I don't need that. I don't need, okay, so this is probably where it is. So 8 point. I had it and then I didn't have it and then I have it again and then no. I completely do not have it apparently, like the section number, and that's all I was looking for was to tell you the section number. And oh, here it is. All right, yeah. So page, this one will be from 8.3. So 8.3, and so number one is from 8.3. And so this will be about these formulas that are they call them the sum and the difference formulas. So I do want to point out though that in a lot of cases, and even in the book that you have, they give them in this form right here. But the reason why I like this other handout is because they separate the ones that are the addition or the sum formulas from the ones that are the difference formulas. So that's actually a little bit of a, a reason why this one might be a little bit better, because you don't have to deal with the like the plus or the minus, because otherwise if you look at this, then what actually happens is that like and there's all different forms of this formula. Do you see that this one, they have the yeah, this one they actually did have a little bit of they did this to you here, and I know that they didn't do it on purpose, but they actually just put a plus over here, but then they put a plus or minus. And so the issue is, like, if you look at the ones that are in the form that the book would be given, then they'll have a, for the cosine one, they have a plus minus, and then it switches to minus plus. So that's where I think that the difference is that you have to pay attention to those like signs switching around. So the way that I would remember these, since it says in several places in the book and in the lecture notes that you should remember them, it's like this. So, and this came from one of my friends who was, an actuary for like years and years and years. So they are sine of, then A plus B is sine A, and then cosine B, and then plus cosine A sine B. So then what he actually, what he actually does is he actually does it uh he does it like this. So he says, oh, and by the way, if you look at it and you say sine A minus B, and then it's sine A, and then cosine B, then minus cosine A sine B. But then if you have the cosine ones, it is cosine A plus B is cosine A cosine B, but then minus the sine A sine B. I don't know why there's a shadow today. I'm gonna turn that light on. All right. So then if you have cosine of A minus B, then it's cosine of A cosine of B plus sine A sine B. So here is what you need to remember. So these are the same signs. Same signs. And then these are like change the signs. So from plus to minus or minus to plus. So change the signs. So then my friend always did this. And for some people, it works. For some people, it doesn't. But he always said it like this. He would say, he would read it or more like a cheer, like sine, cosine, cosine, sine, cosine, cosine, sine for change the sign, then sine, sine. So like that, like sine, cosine, cosine, sine for sine, cosine, cosine, sine, and then cosine, cosine, and then sine for change the sign, and then sine, sine, and then he remembered it like that. But he was one of those people who could make it sound more exciting than I do, because he was also like he does karaoke and he plays softball, and he's like 75, so like I don't know. Anyway, just remember, like if you're looking for a pattern to remember these, this is the way that you can, one way at least you can do this. And so then if you actually like go into a problem, then that is using these formulas, like if you ever see a pattern like this, then you should like think that you're going to go to the adding or the subtracting. So it would be solve the equation for the angle of A. So that would be the first one here, and it's sine A cosine B minus cosine A sine B is 0.227978. So then if I look at the pattern here of sine A cosine B minus cosine A sine B, then this right here, this is equal to the sine of A minus B, which will be 0.227978. So that's why that's why I said that, like knowing the formulas both directions is important. But I feel like it won't be that bad, because either it will look like it's this formula, like one of these four, or it will tell you to use the formula most of the time. So I don't think it's going to be as bad as it seems. But do you have any questions so far? Okay, so then from here, I would just go ahead and find the sine inverse on each side. So sine inverse of sine of A minus B will be sine inverse of 0.227978. So then sine and sine inverse actually go ahead and divide, or sorry, cancel out. So A minus B is sine inverse of 0.227978. And then you can find this sine inverse of the 0.227978 using a calculator there. So that would be A minus B is approximately 0.23000484. But then since it will, of course, usually only be to 3 decimal places, so to 3 decimal places. I didn't say that, but whatever the decimal places say in the problem is fine. So then that would be right here. So it would just round to 0.23. So then add the B. So A minus B is approximately 0.23 and add the B. So A is about 0.23 plus B. And this is still like assuming that you don't know what B is, but it just said to solve for A. So it doesn't matter. So do you have any questions? And like I said, like it really is just like the next few problems at least will use these formulas here. So, okay, so then let's see. Now, I do know that if you now, yeah, I know what question 2 is asking you to do. I'll be honest, like I really do. Like if you, it will be tangent of say something like 15 degrees. So like there, I know what the point of a problem like this is, right? But you, but this all goes back to if you were back in the olden days, you know, like you didn't have a uh yeah, you didn't have a what you call yeah, a calculator, then it would be something where you would want to use the table to try to help you, like not have to go and look up uh different values. But you know, like we are in 2022, so let me show you what I would do. So if it says like use a sum or difference formula to find the tangent of 15 degrees, then there are a couple of formulas for the tangent that are here. So they're these ones. So I'll write them down. Tangent of x plus y is going to be the, here it's tangent of x plus tangent of y over the 1 minus tangent of x tangent of y, or you can use tangent of x minus y will be tangent of x minus tangent of y over 1 plus tangent of x tangent of y. So then what you want to do, and this is all it really is try to find like two numbers on the table that add or subtract to give you 15. So that's what you're going to do. So you want to find two numbers right on the unit circle of values that add or subtract to give you 15. All right, so then honestly, like I don't feel like that's too hard because here's a difference of 15 degrees right here. Right, you can say 45 minus 30 is 15. Or if you want it to, you could even do 135 minus 120 is a 15-degree difference. So all you have to do is like go to the table and find like two values that add or subtract to give you 15 degrees. So then what I would say then is that, like, so for example, 45 degrees minus 30 degrees is 15 degrees, or 135 degrees minus 120 degrees is 15 degrees. So it doesn't matter which one you use. But then once you do that, then you just will use that set of values in the formula up here. So 15 is actually the 45 minus 30. So tangent of 15 will be tangent of 45 degrees minus 15, 30 degrees, 30 degrees. So then the X was 45 and the Y was 30. So it's tangent of 45 degrees minus tangent of 30 degrees over 1 plus tangent of 45 degrees, tangent of 30 degrees. So like I really just think that that's not really, I mean, it's nice, like I said, if you don't have a calculator to be able to just look up the values, but it's still not always entirely practical. But in any case, the tangent of the 45 is 1 and tangent of the 30 is square root of 3 over 3. So you have 1 minus square root of 3 over 3 over 1 plus the 1 times square root of 3 over 3. And I'll admit that they actually do in the book, I think, or like even, yeah, like would leave it like this, but well, actually not like that. They would at least try to clear the fractions, because remember, like you have to type this into the computer at some point, so you don't want to type something messy in. So it clear the fraction. So you can multiply by 3 all the way through. So 3 minus square root of 3 over 3 plus square root of 3, and then leave it like that. But surprisingly, though, if you were to like rationalize the denominator, so this isn't really necessary, but if you were to do this next step, then multiply by 3 minus square root of 3 over 3 minus square root of 3, you would have 9 and then minus 2, 6 square root of 3 plus 3 over, and then 9 minus 3. So then it would be 12. 9 plus 3 is 12. 12 minus 6 square root of 3 over 6, and then 12 over 6 is 2, and 6 over 6 is 1. So it actually, if you were to put it into an online calculator, they would actually give you that, which happens to be the same as that. But this is also why I, like I was saying, it's 2022. So like if a calculator can do that for you, I wouldn't say that I would say that's a bad thing, because you still like, even though like you clear the fraction, this is still harder than to look at than this, So do you have any questions? Okay, yeah, like I said, that's an example of the tangent formula. But then if you look at something like what I'll do next, it's a little bit different because it's one of the angles that isn't on the table. So this only actually works if the angle is on the table. So I, like I don't want you to think that this is the only way to do this one, but it's a, yeah, it's a challenge. I will admit that it definitely can be. So this is from 8.3 also. So if the cosine of alpha is 11 over 61 and tangent of beta is 35 over 12, with alpha in quadrant 4 and beta in quadrant 1, then find the sine of alpha plus beta. All right, so for this one, this is actually a bit different as well. It's they're all like similar, but at the same time a little bit different. So what I want you to notice is that if I'm given a problem like this, I would always actually like write out the formula that you need to use. So first, like step 1, and they don't actually give you any steps here, but write out the identity you need to use to find that sine of alpha plus beta. So that one is, and it's the same as before. So it's that one right here. So sine alpha cosine beta, and then plus cosine alpha sine beta. Now, what I really want you to see is what part of the information have they already given you. So they gave you cosine of alpha is 11 over 61. So you already know that's 11 over 61. So that's actually one thing that you already know. So that would be next. Then identify the quantities you already know and what you need to find. So then, all right, so we know that we need to find the sine of alpha first. So let's find the sine of alpha, this one right here. And so we know that what we know is about alpha is that cosine of alpha is 11 over 61, and alpha is in quadrant 4. So I'm going to draw that, and in the online practice quiz, they'll use the formula method, but again, like I really think that if you deal with the formula method, then if you the numbers get really large sometimes, and then you forget to take the negative when you take the square root sometimes, and it just it can be a problem because it doesn't like show you like how what we did way back in chapter the 7 at the beginning like applies now still. So it's the same idea. We're in quadrant 4, so the reference angle looks like this in quadrant 4. So this is a quadrant 4 reference triangle. So, quadrant 4 reference triangle. And then what you know is that this will be the alpha, and cosine of alpha is 11 over 61. So we're still going to go back to adjacent over the hypotenuse. And so the 11 is right here, and the hypotenuse is right here. So what we need to find the opposite side still, because otherwise we won't be able to find sine of alpha, because sine of alpha is opposite over hypotenuse. So this is actually the same. If you think about it, right, this is the same type of problem as chapter 7, but there's two triangles going on, because you're gonna need to find the cosine of beta and sine of beta too. So you need a different triangle for those, but they told you tangent beta was 35 over 12, and beta is in quadrant number 1. So it's really these types of problems, they're the same problems, but it's what you do with the steps to tie them all together. So I will say then, like, to find this opposite side, you use the Pythagorean theorem. So then you know that C is always the hypotenuse, and that can be A and that can be B. It doesn't matter. So A squared plus B squared is C squared. So 11 squared plus B squared is 61 squared. And then you have, it should be, I don't know what 61 squared is. I think it's, yeah, 121 plus B squared. I think this is 3,721. So then if you subtract that, you get 3,600. And so B is plus or minus the square root of 3,600. So B is plus or minus 60. Oops, sorry, you can't see it, but 60. So because it's down in quadrant 4, this has to be negative because it's a negative y value. So this point is actually the 11 and negative 60. So that's why I think drawing the triangle helps, because then it like, oh, well, it's going down. That opposite side is going down. So it has to be a negative value. And then from there, that's when you can just go along and say, well, all right, this is okay. I know that then sine of alpha is opposite over hypotenuse. Opposite was negative 60, hypotenuse was 61. So I know that is actually the negative 60 over 61 then. So where is that at? Yeah, so that would be that value that gets substituted in right, oh, sorry, right up there. So we have 2 of the 4 values that we need now. So like the only thing I think that excuse me, that would maybe help make this one a little bit easier is that it is in quadrant 1, so you know that they're both positive. But other than that, they didn't really give you much hint. So in quadrant 1, this is what the reference triangle looks like. So this is a quadrant 1 reference triangle. So this is beta. So quadrant 1 reference triangle. I'll abbreviate with just a triangle symbol. So then tangent of beta is 35 over 12. Tangent is opposite over adjacent. So opposite 35, adjacent 12, and we need to find the hypotenuse. So we need to find the hypotenuse. And so that is the Pythagorean theorem. So 12 squared plus 35 squared is c squared. And so if you do that, then that will be, what is it? It's 1369 is c squared. And then you take the square root. And of course, because it's the hypotenuse, it's always positive. So c is the square root of that, which is 37. So then remember, you need the cosine of beta, which is adjacent over hypotenuse. So adjacent is 12, hypotenuse 37. And then you need the sine of beta, which is opposite over the hypotenuse, so 35 over 37. So then you know the other 2 values that you need to substitute in. So do you have any questions or anything even that you want to go back to or ask about this? It's, it is what it is. Like once you break it down, I hope that it doesn't seem like too bad. I do know that, yeah, it probably does seem a little bit odd at times to do it this way, but it really isn't as bad as it seems. Okay, then let me go to the final answer here. So the final result then is if I substitute this all in, so sine alpha cosine beta plus cosine alpha sine beta, this will be negative 60 over 61 times the cosine of beta was that 12 over 37. And then cosine of alpha, they told us was 11 over 61. And then sine of beta was the 35 over 37. So if I do that, and yeah, you do need to like do the, like at least like add these together, but you don't necessarily need to simplify or reduce. But if you did that, it should be what, negative 720 over 2257 plus 385 over 2257. So that gives you negative 335 over 2257. So I would give that as the final answer. So yeah, are these like a lot of steps? Yeah, but like, do I think that you can do it? Yeah, absolutely. Like I think it just takes a little bit of practice to make sure that you get the angles correct. But do you have any questions? Okay, then let me do one with the cosine and then one with the tangent, just so that if you end up seeing that they're slightly different, it might actually uh like like I feel like sometimes if people only see one, then here I am gonna stand up because this is the the desk is like I don't know if it's too low or what, but sometimes I feel cramped. So then let's see, let me move the paper though, because I had it like a different place when I was sitting. So, okay, so then this one is very, very similar here. So if the sine of alpha is 11 over 61, and the cosine of beta is 21 over 29. And this is where the alpha is in quadrant one, two, and the beta is in quadrant four, then they want you to find cosine of alpha plus beta. So then the same idea applies here. What I would do is I would start by step one, write down the identity that you need to find the cosine of alpha plus beta. So if I do that, the identity that I need is actually it's cosine of alpha plus beta was cosine alpha cosine beta minus sine alpha sine beta. Now, oh, sorry, I put a plus and not a equal, but I said plus, but all right. So then this one I would say is even easier in a little way than the last one because they already gave you two of the uh, pieces of information that you need. So they told you that sine of alpha was 11 over 61, and they told you that the cosine of beta was 21 over 29. So they told you two things already. So you only have to find the cosine of alpha and the sine of beta. So then, yeah, so identify so that would be sort of step two is identify the quantities you already know and what you need to find. So then you know that you need to find still the cosine of alpha and that you need to find the sine of beta. So those are the two things that you are the two quantities that you need to find, but the way to find them is really the same way as in the last problem where you know that you can draw the triangle, but they told you that sine of alpha was 11 over 61, so that's opposite over hypotenuse, and they told you that alpha is in quadrant two. So this is a quadrant two reference triangle. So this is how they look in quadrant two. So there's my quadrant two reference triangle. And then here's my alpha. And then I just label the opposite in the hypotenuse. So this is 11, this is 61. And then I use the Pythagorean theorem to find the adjacent side. So we have, well, it doesn't really matter how you do this, but 61 squared minus 11 squared will be the b squared. So then I will say that at this point, what do you get? Because I think I wrote it, I have already written down, but I don't actually. Yeah, it's 3,600, I think. Yeah, 3,600. So 3,600 is b squared. And then when you take the square root, it's plus or minus the square root of 3,600 is b. And then that will be plus or minus 60 is b. But because it's in quadrant 2, this is going to be negative. So negative 60. And again, it might help that this point right here is negative 60 and 0, so that you know that it definitely is negative. So that's why I like drawing the triangle still, is because it like helps with that. But since you want to find the cosine of A though, or cosine of alpha, that is adjacent over hypotenuse. So negative 60 over 61. So that's one of the missing values. And then you can go and find sine of beta. So same idea, because they told you cosine of beta was 21 over 29. So that's adjacent over hypotenuse. And then they told you it was in quadrant 4. So in quadrant 4, the reference triangle is down here. And then you know that this is the beta. So adjacent is 21, hypotenuse 29. So you need to find the opposite side. So that's the Pythagorean theorem again. So it's 29 squared minus 21 squared is, again, whatever letter you want to call it, but maybe a squared, it doesn't matter. And so 29 squared minus 21 squared is 400. And then you take the square root. And again, in this particular case, even though it's plus or minus 20, because it's in quadrant 4, it will be negative. Oh, sorry, you can't see that. I'm telling you, like, I moved this up again and then it didn't. I'm just going to zoom it out a little bit because it keeps on doing that. And because here, that's better. So then that means that the sine of beta, because it's opposite over hypotenuse, is negative 20 over 29. So I really don't think that this is like that bad. You just have to like write down the formula that you need and then make like 2 triangles, like do 2 of the triangle problems from chapter 7, which yeah, like, I mean, that's all it is. It's like 2 of the problems from chapter 7, and then substitute the numbers back in. So in step 3, then you just substitute the values into the identity. So that would be, all right, so you had cosine of alpha, cosine of beta minus sine of alpha, sine of beta. So cosine of alpha, we just found negative 60 over 61. Then cosine of beta, they told us way at the beginning was 21 over 29. Then sine of alpha, they told us way at the beginning was 11 over 61. And then sine of beta, we just found negative 20 over 29. And then if you do this, then you will get a oh my, a negative 1260 over 1769 plus a 220 over 1769 for a final answer of negative 1040 over 1769. And again, like you don't have to reduce this. So you can, but you don't have to. So like after doing all of that work, I'd probably, if it were me, I wouldn't go and reduce it. But anyway, do you have any questions or anything you want to see again? Because it really is like one of these things where when you have to like put everything together from all of the previous chapters like this, it can become it can become a bit messy, but it's just, if you know the identities, it's easier, I think, like, but don't memorize them like right away. It's just something that you have to take time to do, right? So, all right, then let's see. Let me look at the next one then. And this one will be number 5. And this one is actually even easier than that one because it just, you'll see in a second. So it says number 5, I'll do it still from 8.3. So if cosine of alpha is 12 over 37 and the tangent of beta is 5 with an alpha in quadrant 4 and a beta in quadrant 1, then find the tangent of alpha plus beta. All right, so the same idea will apply. Like step 1, what you're going to do is you are going to find write down the identity. So write down the identity you need. So that will be tangent of alpha plus beta. And the good news again is that this one, it doesn't matter if it's like X and Y or alpha plus beta. So tangent of alpha plus tangent of beta over 1 minus tangent of alpha tangent of beta. So like I was saying, the good news is that they told you tangent of beta. So you actually only need to find tangent of alpha. So you only need one triangle to solve this problem rather than 2 of them. So you only need to find tangent of alpha. So then for step 2, then what we're going to do is we're going to find the missing values. So in this case, find the tangent of alpha. So like I said, I think that was actually a easier one, given that they told you like tangent of beta. If they would have said like sine of beta or something, then it would have been a little bit harder because you would have to like find the missing side to still find the tangent beta. But here, then if you look at what's going on, alpha in quadrant 4 and cosine of alpha is 12 over 37. So you can draw the quadrant 4 reference triangle. So it looks like this, and this is alpha. And you know that cosine of alpha is adjacent over hypotenuse. So here is 12, here is 37, and you use the Pythagorean theorem to find the opposite side, the side that's missing in this case. So 37 squared minus 12 squared is a squared or whatever variable that you want it to be. And if you do that, that's actually 1225. And then you take the square root. So plus or minus the square root of 1225 is a. And because it's in, well, you can find that that's actually 35. So plus or minus 35. But because it's in quadrant 4, this is actually negative. So negative 35. And so again, all you needed to find was tangent of alpha. So therefore, tangent of alpha, that's opposite over adjacent. So negative 35 over 12. And then step 3 is to substitute the values into the identity. So I don't feel like this is too bad, but you just have to be careful about what is happening here. So substitute the values into the identity. So we have tangent of alpha plus beta. Tangent of alpha was negative 35 over 12, then plus tangent beta, which is 5, then 1 minus the tangent of alpha, negative 35 over 12 times tangent of beta 5. And then if you do a little bit of simplifying, and again, I probably would multiply through by 12 just to make it a little bit easier. I don't know if it does, but it might. So you have negative 35 plus 60 over 12 plus 175. So you have 25 over 187. So do you have any questions or anything that you want to ask? Because I'll tell you, like the next set of 3 problems, and I guess I was going to do like about 3 more today, because there's actually, this is a longer practice quiz, because there's like we have these sum and difference identities, and then we'll do the double angle identities, and then there's the half angle identities, and then there's solving the equation. So there's like, it's a bit of a longer chapter, but 8.3 has the double angles and the sum and difference in the same section. But I feel like it really is one of those things again where I think you need to like practice them, like instead of like seeing them all jumbled all together. So
I just had a quick question. For the formulas like cos A alpha plus like beta, do you know where we can find like a sheet like that shows like all the formulas? I know you had something like that, but
yeah, so I honestly like would use the one that I put in here, because that is actually like those,
okay,
like
perfect. Yeah.
yeah, it was those 3, the 3 that I was using today are these 3 and these 3, and then next week we'll use these half and double ones. But those are really the only ones that you would really need for this class, actually. So like there's more of them, but like they're, I don't know, like if you look in that folder, there's more formulas, but they have to do with like shifts and like yeah, like, oh, and actually this one, if you want it. This one might have more. I don't know like what you're looking, like how much you want, but I put them all here for that reason. But this is like trig sheet. So this one actually has a little bit more because we'll only do the double angle, but this one has triple angles. So like I said, like you can do more and more and more, but I I don't know. At some point you have to just stop, because our class will talk about laws of sines and laws of cosines, but there also is a law of tangents, but we won't do that, but it exists.
Yeah, I just
But
need the formulas for the first one, but
yeah, so I will say though that the law of tangents is interesting because there's actually a real reason why no one really talks about it that much. So I like it, yeah, so it just kind of is out there and it exists, but you don't you just don't talk about it. All right. Let's see. So number 6 here. So number 6 and still in 8.3, but this is find the exact value of sine of cosine inverse of 84 over 85 minus sine inverse of negative 20 over 29. So all right, this is where I I think it gets a little bit tricky in terms of like what you need to remember that you need to find. So I just want to make sure that I tell you the right formula. Okay, so you have the sine of something minus something. So you have to think of it like sine of and then a minus b, whatever that is. So it doesn't matter that this is, it looks like this. It just, that's unfortunately the how it looks. So then what's going on then is what you're going to do is the same thing as before. So you're going to, oh, and they didn't, yeah, so just remember that this is like sine of the a minus b is, and I, again, I really feel like this is just they do something bizarre when you do it, like solve this using the formulas. That doesn't happen when you draw the triangle. So using the formulas again, sine a cosine b minus cosine a sine b. All right, so here is where I feel like you have to be a little bit careful, but I I do think that you can do this. So the A was the cosine inverse of 84 over 5. So whatever that A is, I'm going to substitute here and here. And then whatever the B is, I'm going to substitute here in here. So what I have is, and I'll write it over here just to, you should have enough room, but I don't always write the smallest. So sine of, and because A was cosine inverse of 84 over 85, then I'll write that like this. And then cosine of B, which is that sine inverse of negative 20 over 29. and then we have minus cosine of A, which is cosine inverse of 84 over 85. And then we have sine of B, which is sine inverse of negative 20 over 29. So then if you think about it like this, then this is just unfortunately or not, right? It's a whole bunch of the problems from the last chapter, like all put together, right? If you remember ones like this, like we where we talked about this, and then you when you do something like this or this or this or this, I I want you to remember this part right here, and it's that for the drawings that we had, if you have cosine inverse, then remember that for cosine inverse, it's in quadrants one or two, but then for the sine inverse, remember sine inverse, it always is in quadrant one or four, but we never use quadrant three. So we're still not using quadrant three, but I wanted to uh, point out that this is actually the same idea as before. So we're just doing a bunch of the problems from the last chapter all put together there, but yeah, so I think that's actually it. That's actually good, I think, because yeah, so all right, I want you to notice though, do you see that uh which ones were which? I should have highlighted them again, and I don't remember which ones were which. All right, so this was the B, right? And this was the A. So do you notice that the because the sine inverse, right, has a negative 20 over 29, that means it's in quadrant four. So sine inverse, since the 20 over 29 is negative, then that means we're going to use quadrant four. And then for this one, we have cosine inverse, but since the 84 over 85 is positive, we're going to use quadrant number one. So what I'm saying then is that for the cosine inverse, since we're using the quadrant one, we're going to draw the triangle like this. But then for the sine inverse, since the 20 over 29 was negative, we're going to, draw the triangle like I shouldn't have done that. Sorry. This is okay. We're going to draw the triangle like this. So do you have any questions so far? Because okay, so this is why I guess I was saying, like, like once you get past like the earlier chapters, like if you really know those well, then you just like you're like, these are just rearrangements of the problems from the previous chapters, like, and you just have to do them again, and and then substitute the numbers into the formulas. Um so then if you remember what's going on, then just remember that you have to then use uh, the the formulas that they have here. So which one do we want to find? We want to find I'm trying to remember what we're trying to find here. Yeah, sorry. I was over in space somewhere and I'm not sure why, because this is actually yeah, so cosine of theta will be the, remember, x over r. So remember you have 84 over 85. So here is the 85 and then here is the 84. So then you use the Pythagorean theorem to find the other side. So use the Pythagorean theorem. So then what do you have here? You have 85 squared minus 84 squared is, well, that is going to be 169. So that's like b squared. So 169 is b squared. So the square root of 169 is b. So b is 13. So that right here is 13 then. So then once you do that, all you, and by the way, like if you want it to say like instead of x over r, like a adjacent over hypotenuse, like in the like before, like I'm not gonna stop you. It just I want to remind you, you could say x over r here instead. Like it's not really like a big deal if you say x over r adjacent over hypotenuse. It really doesn't matter here. But then from there, you can find the sine. So the sine of this is actually going to be so therefore the sine of that angle will be the y over r, or opposite over hypotenuse. So 13 over 85. So all I know now is that this whole thing now is 13 over 85. That's what I just found. All right, and now I need to find this whole thing now. So to do that, then I go to this triangle right over here. So actually, I'm gonna draw that one over here so that I don't have all of the information sort of like all over the place. So that one will be down here. But remember how this works though. We start with the inside function. So the sine of theta then will be the 20 over 29. But remember that, oh, sorry, negative 20 over 29. So that will be the y over r. So this will be negative 20 and this will be the 29. And then you can use the Pythagorean theorem for this side right here. So use the Pythagorean theorem. So I don't know why my pen is doing this. I think the ink might be almost gone, which, oh, well, use the Pythagorean theorem. So then what do you have? You have 29 squared minus negative 20 squared is, again, whatever letter you want to call it. But if you call it a squared there, then that will end up being 441, which is a squared. And if you take the square root of 441, then you have square root of 441 is a. So that will be 21 is a. So there you go with that, because it's in quadrant one, it's positive. And so therefore, remember, you need to find uh, the, the outside function value for that angle. So cosine of theta is then x over r, or adjacent over hypotenuse. So that will be 21 over 29. So that means this whole thing right here is the 21 over 29. So I'll zoom out a little bit. And then if you like cosine and cosine inverse, those cancel out as long as you're in the correct quadrants, which is why I made sure that we were in the correct quadrants before we started. And then sine and sine inverse cancel out again if you're in the correct quadrant. So this is 84 over 85. And this one right here is negative 20 over 29. So your final answer is then 13 over 85 times 21 over 29, then minus 84 over 85 times a negative 20 over 29. So you're left with a 273 over 2465 plus a 1680 over 2465. So at 1953 over 2465. All right. So sorry. So again, I don't think that this is actually yeah, I don't think that this is too bad, but it's all about the fact that you have these like multiple problems inside of the same problem, you know? So do you have any questions about this? Okay, so I was gonna do more, but then I realized like this is already probably a lot. So like because it's sort of the next two are very like similar, but I kind of, now that I looked at them again, I kind of want to like save them for next week, and like just in case like you start doing them and then you start looking at them and thinking that they're are harder than they are, then we can at least use those ones to sort of review what we did today. But I did want to say that I I don't know yeah, I'm not 100% sure that I will be able to have the lecture next Thursday. So I want it to still have two next week, or even three, because it's a longer chapter. So I was going to probably, yeah, I was probably my initial thought was when I realized like I may not be able to have the lecture next Thursday, that I would have one on Monday and Tuesday and Wednesday, because it's such a long chapter. But that I realize also that's a lot of extra like time. And so if so, Christina, like if you had to pick, would you rather have the extra one on Monday or Wednesday, or just have a longer one on Tuesday?
I think that, I mean, if you wanted to split it up, I would just do, because the test is on Thursday. So I think your best bet would be to split it up between Monday and Tuesday, because I feel like if you just had one long one on Tuesday, it would just be like
Yeah,
too much.
okay.
That's just my opinion, but I feel like if
Yeah,
you just did Monday and Tuesday and got it over with in those 2 days, we would have enough time to like look over it
yeah,
Wednesday and Thursday, if you know what I mean, you know?
yeah. So is Monday at 10 o'clock still okay for you?
Yeah, yeah,
Okay, because I can do a different time, but like as long as 10 o'clock is okay with you, then I'm okay with that.
yeah,
So, so yeah, so we'll just meet on Monday instead because I was also thinking the same thing that you were thinking, that like if we were to have the lecture on like Thursday, like usual, that it would be too close to the quiz anyway.
yeah. It
So
is.
like I think, yeah.
Yeah, I think if you did it on Thursday, it's just like it would be too much to like register, you
Yeah,
know?
so I agree with you. So we'll plan for Monday then, and I'll put the correct Zoom link in Canvas for Monday, and then like I said, like 7 and 8 are sort of like the same type of problems, but there's like it will be sine of A minus B and tangent of A minus B instead of or cosine of A minus B instead of sine of A minus B, so I don't think that it will take you a long time to get the general idea. I do think that like it might take a little bit of time to like get used to these problems because they're so long.
Yeah.
But did you have any other questions though?
I did have like one more thing. I
Oh
do
yeah.
start a chemistry like hybrid class, but the thing is that that class is between